Back in 2011, when I first heard about 3D printers, I knew I had to build one. Up until that point, the closest thing I had to making my own plastic parts for things was something called polymorph, which is a hand moldable plastic that softens at about 60 degrees Celsius. Unfortunately, I had next to no money, and this was before you get cheap mass-produced 3D printer parts. I thought I'd show what I ended up making and how I made it. So I had this idea to build a sort of scaffolded printer frame based on threaded rod. Everything was going to be right angles, so I bought a load of 13mm brass nuts and I brazed them together at right angles. This actually worked surprisingly well. You can see it produced one of the most ugly printers imaginable, but it did print, and that was the most important thing. Another odd thing about this design was that I decided to make it so that the build plate moved on both the X and Y axis, which I really have no explanation for, as it's probably the worst way to build a 3D printer. Anyway, the next issue, now that I had a possible way to actually build the frame, was the moving parts. You might be thinking, well, there's so many options: linear rails, linear bearings, V-slot. Yes, there are those options, but at the time I decided that I would use round aluminium tubes. Now you might be thinking, surely those are not straight enough or strong enough for this purpose. And the short answer is no, they weren't. So then, given I wasn't using smooth steel bars and linear bearings, how is the machine going to move along these aluminium tubes? Well, my answer to this was basically design it like a roller coaster wheel. The thing is that there were some things I had in plentiful supply, like 8mm threaded rods, 22mm skate bearings, and polymorph plastic. So essentially everything had to be made from these in some way or another. One of the core parts of a 3D printer is the hot end. Nowadays you just go on Amazon and just get a hot end for like £10. But I didn't have that option, so I took a smooth steel rod, cut it to about 50mm long, then took a hand drill with a 3mm drill bit, and I drilled as straight as I could down by hand through the middle of the rod. Then brazed a brass nut to a copper tube, and then to a 0.5mm copper MIG welding tip, and that was the foundation of my nozzle. But then how do you actually heat this thing? For that, I used nichrome wire, which is like resistance wire, and I had to sort of wrap it around the nozzle somehow, but you can't just wrap it straight onto a bare copper nozzle because it just short circuit. So I put a thin layer of fire cement on the nozzle, waited for it to dry, then I wrapped the nozzle in a coil of nichrome, and then a final layer of fire cement. The length of the nichrome heating element determined the resistance and allowed me to tune it to an appropriate resistance for 12 volts. Then I used a glass thermistor cemented in place as well to measure the temperature. So I was using ABS plastic for this printer, ABS filament, and ABS is known for the most horrendous warping imaginable, and it's basically impossible to print without a heated bed. So my next problem to solve was making a build plate and then figuring out how to heat it. So I rummaged around my parents' garage and I found an aluminium plate. I wrapped Kapton tape around this, which was an early build surface for 3D printers. This was somewhat okay as a print bed, but I needed some way to heat it. And I realized that there are these perfect heating pads inside ordinary hair straighteners. So I went to Argos, which is like a catalogue shop nearby, and I got the absolute cheapest hair straighteners I could possibly find. And I bought 4 pairs of them. These were so cheap that one of them didn't even work. Like the wires had been cut when they put the case together. And I stuck them to the aluminium using epoxy and thermal compound. The only issue with these straighteners is that they ran on 230 volts AC, which is live mains voltage in the UK. And that meant that the aluminium plate had to sort of be right next to the live mains voltage. So anyway, I was just careful not to die while using it. So now I had the frame, the rails, the heated bed, the nozzle, but I didn't actually have an extruder. So I thought, what do I have? Oh yeah, threaded rod, polymorph. So I took a section of threaded rod, cut grooves into it perpendicular to the threads to create a knurled surface. This is what would grip the filament. Then on the other side, I compressed a 22mm skate bearing against the other side of the filament, and this was all encased in polymorph to create this mutated looking extruder. To drive the extruder, I used a stepper motor connected via 2 remote control car gears to increase the amount of torque. So now everything's coming together. I had essentially everything I needed, and everything else could be made from polymorph. I just needed the electronics. This was the part where I'd had to spend some money. I bought a 4-axis CNC stepper motor controller board to control the motors, and this was the single most expensive part of the project. The issue with this thing was that it used a parallel connection, which I remember being such an absolute nightmare to use, but it did eventually work, and I was able to control the printer with it. To control the heater and sensors, etc., I just used a breadboard and plugged everything into that with a few MOSFETs for switching. The problem is that breadboards are not designed for such high currents. They're meant for maybe like 1 amp at most. So inevitably it started to melt while running for any length of time. But don't worry, I had a smoke alarm just above the printer, so that made it totally safe. I then used a software slicer at the time called SkeenForge. This was a collection of scripts that would take your STL file and convert it into a G-code file. If you do any 3D printing now, you're probably used to this process taking like a few seconds in something like Cura, but SkeenForge would take sometimes over an hour to generate the G-code for a model, not even a particularly large model. So the iteration on the settings was just extremely painful. So now this printer technically worked. You could physically print things with it, but it was honestly pretty awful. The tubes would bend, the extruder was a nightmare, the nozzle would leak and melt, and it was basically an electrocution waiting to happen. So in 2012, I decided I would build a new 3D printer, and I had this sudden brainwave, and I realized that wood existed. So I started designing this new structure primarily based around MDF. Apparently, by this point, I had also discovered that smooth rods and linear bearings existed, which made the whole thing 100 times easier. I was also able to buy a printed PCB heated bed assembly that actually ran on 12 volts and didn't bend or anything when it was heated. In terms of the extruder, fundamentally the assembly remained the same, except it was now based around 2 wooden side plates through which everything else was mounted. This design was also the first one that I entirely 3D modelled on an ancient program called Caligari TrueSpace, and a few parts of the machine also continue to use those right angle brazed nuts as you can see on the pictures here, and I also use polymorph in some places to mount awkward things like the stepper motors. It really is amazing how difficult your life is if you don't already have a CNC machine to make your CNC machines. I was also lucky enough at this point to acquire a 3D printed set of gears for the extruder, which were more appropriate than the remote control car gears I'd been using previously. Believe it or not, I actually used this printer for probably a few years before I actually ended up buying a 3D printer, and it did work. You know, it wasn't perfect, and when it broke down, I probably spent more time repairing it than it actually spent printing, but it provided a way to 3D print when I had no other way. If you don't have a 3D printer, then any 3D printer is better than none. So anyway, that's the story of my first 3D printers. Thanks for watching.